In this tutorial, we're going to look at event-driven programming. It means that our code is learn upon activation of events, for example, clicking buttons. It fires action event, and then events is actually object created from event source. Then event handler processes the events to simply saying that string message shows on screen. So let me just write it down. There are many different ways of implementing or doing event-driven programming. We can just use traditional classes and then invoke the APIs available in events classes. And then we can implement the interface. By doing that, we can do that as using inner class, or we can use autonomous inner class, or also we can use the Lambda expressions. I will show you them all. So we assume that we have a class. In this case, we are dealing with a graphic user interface. So let's say we have multiple buttons, text box, labels, and so on. For simplicity, I will say OK button. When you click the OK button, it's going to return string value. Then when we click the button, it's supposed to react. That's why we call it as a triggering event. That depends on or implement methods belongs to event handler interface. It has one method called handler. Again, this is abstract methods because interface can have only abstract methods. So when you implement event handler interface in my app, we must implement handler methods. It means we have to override it so that we can make the button actionable. Dashed line with triangle. And then here, for simplicity, I will say button. But has one method called setOnAction. It should be implemented with event handler interface. So simplicity here, I have a one button. So if you want to do a grab user interface, then you may have a multiple buttons or grab user interface obligations. But if you need events triggered by button, then you have to implement event handler interface. Generally, this is the overall idea. So you have a button class, many of them possibly. Then you have to implement an interface called event handler so they can deal with action events. So event handler interface, extend another interface called event listener. So it means that your class or your objects are waiting for the actions. So for example, when user click the button need to know whether it is clicked or not. It means it's something to do with the event listener interface. So basically say we are making objects to be able to listen users' action. So most important keyword is here, action event. Action events is one of the class extended from event class. So action events usually deal with the buttons. We have input events and then mouse events. This example, I will focus on action events. So event is superclass of action event, also superclass of input event, and then mouse event. Input events also has two subclasses you may need to know. One of them is mouse event, key event. Sorry, I said I made a mistake. Subclass of events should be action events, input events, and then window events. Sorry. Input events has mouse events and key events. I'll fix it. So we know that event handler, we have to deal with action events class. So it means when you're dealing with the button, it will provide events source object, like an OK button, you can name it after button class. And then with this in my app, you may have two buttons, two objects. One of them referring to event object. That is the based on action event. And then you need another object that deal with event handler interface. So I call it as an event handler object. So those two objects must be in your apps so that we can deal with events, we can deal with interface that help us to deal with action events or event input events or window events. So basically say event object refers to button, and then event handler object refers to event handler interface. Create a new project, Java application. For JavaFX application, we have to extend application class. So we are looking at here on JavaFX application. Again, this is abstract class import, and it has an abstract method. Just call it as start. Just say start method, one parameter called stage and primary stage. For simplicity, we can launch with argument. That's going to help us to launch JavaFX application with this NetBeans. So here, let me remove. So ideally, we call it as we need a pane, we need a scene. The stage refers to what we know as a window. But in JavaFX, we call it as a stage. So stage and the window is the same thing, okay? So in general, to create a simple window, we need a stage. On top of that, we need a scene. Also, we need some sort of a layout that is referring to pane. Then we can have components like buttons. So basically, each window or stage has multiple layers. So create a pane, sometimes we call it as a container. One of the popular container is HBox, refers to horizontal box. So whatever we put it, all those components or controls up here and left to right hand side in order. I just put some spacing for pixel 10 pixel size. This is how we create a button object. I name it as a btn OK, new button. It has a constructor with a one parameter string value. I will say OK. So we have a button with a label called OK. Now AWT, okay. We use JavaFX. AWT refers to Abstract Window Toolkit, old JDK version of dealing with the graphic user interface. Create a scene and place button in the stage. So when you have a stage or window, we need a scene. That's another layer. Then we can place button to that scene. And normally scene has a container too. I know it seems very complicated, but I do have a separate JavaFX tutorial. Please have a look after this lesson. Stage. Because the stage is the window, now we can have, let me change the stage, simple name. We can set scenes, let me just set the title first. Normally I put the title first. Event-driven programming. Define the title of the stage. Your little window has a title on your title bar. we have a stage underneath, or top of the stage we have a scene. Top of the scene we may have a container, in this case hbox, and the hbox has multiple buttons eventually. So last one is the stage and dot show. Okay, so it just show you window or stage in Java Apex. We have a title and minimize, maximize, and close button by default. We did not place any button to our container called hbox. So let's do that. There will be a multiple buttons, so maybe 3-4 of them, depends on how we implement event-driven programming. So here code it as get children, get the list of children of these parents. So basically saying we are adding multiple buttons eventually, but at this point let's say one by one. Not very descriptive, but just saying that button OK will be added to hbox. So in other words, hbox works as a parent and then take care of children, in this case button OK. Let me create a new class called OK button handler. Because adding button to container doesn't do anything. So we need to implement interface called event handler. And dealing with the action events class. So here button, it says that when a button is pressed and released, action events happens. Okay, so that's why we need to use action events. Implement Java Apex, not old one, not AWT. Java Apex events, action events. Okay. Again, we need to import Java Apex event handler. This time we are implementing interface, so we have to implement abstract methods belongs to interface. We have only one, handle methods, that has a parameter as an action event. Object name is events. So what we are going to do is system.out.println, OK button is click. So we implement event handler interface. We should be able to use it here. So let's create an object based on OK button handler. Maybe I would just say handler 1 or handle 1, 2, 3, 4 eventually. Now our object. Now we have to invoke that method through a button OK, because the button OK is the object, what we call it as event source object. They should be able to trigger action events here, isn't it? Say button is fired, blah blah blah. It says that it will invoke the fire methods. Basically saying when button is clicked, it will trigger the events. That events is based on event source object called handler1. So we have one button. When you click OK button is trigger, and then it will process the events. The events is basically saying print OK button is clicked. Implementation is not typical, but the idea of using event-driven programming seems complicated. So here we implement event handler. Then we have to override handle method. That is abstract methods belongs to event handler interface. How do we do that? We have to do that through event source object called btnok using setOnAction methods. They allow us to trigger event source object or event object. So that's how we implement it. We can say how we do event-driven programming. So when you have 4 buttons, you need to have 4 additional classes like OK button, cancel button, reset button, print buttons, and so on. But in general, we don't do that. Okay, we call it as an inner class. Inner class is useful because those buttons will be used for this application only. That means we can embed it, or sometimes we call it as a nested class. Can use it within this class. So idea is inner class is defined within the scope of another class, this case Java application 71.java. Idea is cancel button and OK button, all these buttons is going to be used for only this class. So basically it is not necessary to have multiple classes, so we can embed it. And then NetBeans and other IDEs often do that when you use code generation. So you should get familiar with the idea of using inner class, eventually autonomous inner class. So here exactly the same, let's say public class, cancel, handler, implements event handler interface that deals with the action events class. We need to implement abstract methods, belongs to interface. I'm going to simply print cancel button is clicked. That's it. In practice, when you define inner class like a cancel handler, we often make it as less visible. So if your main class is public, we make it as a default. If its main class is default, then we may change to protected, for example. Let's go back. Here we are going to do cancel. Let's say add OK button to make it clear. So this is going to be cancel button using inner class. Okay, cancel button handler, and then handler number 2, cancel button handler. And let me check. Okay, cannot find symbol. Oh, okay, cancel button handler. Now it's okay. Okay, let's say cancel, sorry, btn cancel, set on action according to handler 2. That's it. That's how we implement cancel button. So this button is invoked whenever the button is fired. This is a convenient. That's why we open use inner class. Cancel button is clicked. Works exactly same. So instead of using traditional separate classes, we like to use inner class. Let's add another button called reset. Same story, and we'll say reset, set a label for that button. Reset button. It's going to be looks very similar. So let me add another button to our container called hbox using getChildren method. So graph user interface is done. So this is the idea. When you use this part, this class actually implements the event handler class. So when you use an anonymous inner class, you don't use a keyword called implement. Okay, what you do is construct an object based on interface. But the object doesn't have a name on it, so we can start with new here. What we are trying to do is implement the interface. We are going to focus on abstract method. So we cannot use the keyword implement, so we will focus on event handler, action event. That will give us a warning to implement the abstract method. So here we say new event handler, action events. That's the one we are dealing with, the button. Implement here. Abstract method belongs to event handler interface. And then what we want is just print a message. Reset button is clicked. I know coding is difficult to read at this point, but in terms of implementation, it's simpler. You don't even have to define the additional class. We can just use anonymous inner class. The class, we don't have a name on it, but it does exactly the same. Button reset, set on action, firing event based on object doesn't even have a name. What we call it as an anonymous inner class. Then we focus on overriding abstract methods called handler. Handle. So it does exactly the same. Reset button is clicked. Let me add some comment. Handle this method. We are overriding handler method. we are overriding handle method of event handler interface. Let me add another button so that I can show you Lambda expression, something new. It's even simpler. How to lead, how to follow the coding, but it will be even simpler. 2-3 different way of doing Lambda expression. I will show you something more simpler at the end. So we have a previous button. This one I'm going to use Lambda expression. So normally if you don't use Lambda expression, that's okay. Anonymous inner class is good enough. Most of the time IDEs will generate anonymous inner class for us. As long as we know how to lead it, that's okay. So Lambda expression here, we use a special symbol, looks like a dash, and then greater than. So we name as event that refers to action events and events object. Looks like a dash and greater than. Here we focus on what we like to do. So compared to anonymous inner class, a lot simpler, okay? If you don't like the events, you can use a short name called E or EVT. Either of them is okay. E is okay, EVT okay, just name your object. Like line number 54, like events. I like to use the same name, events, more consistent. So dash greater than will implement abstract method called handle. Okay, let me add button previous to our container called hbox. Okay, let's run it. So we have OK, cancel, reset, previous. For Lambda expression, we can actually call for a method. So let me copy paste it so that I can call for method that can even simplify more than what we have at this point. So here what's important is inside system.out.println, previous button is click. So of course usually we have multiple lines of coding so that we like to modularize it. Let's say print previous. Go down here somewhere, public static void print previous. System.out.println previous button is click. Okay, that's it. It works exactly the same. Let's look at is there anything we can do even smaller or shorter. This time we are going to focus on actual implementation. So after event Lambda expression here, we are going to learn print previous method. So let's focus on that. So we focus on print previous. We don't need a semicolon, we just need one of them. Curly brackets we can remove. That's it. Call lambda expression and run print previous methods. Very simple expression, but a bit difficult to read. Looks strange, but that's the idea of a lambda expression. Simplify our coding. Let me have a look. Is there any mistake or not? So let me add some comments. So at the beginning, OK button, we define a handler class that actually implement event handler interface. Then we register with btn OK, set on action. That's what I mean by register handler object called handle1. Source object we are referring to btn OK. Handle object, of course, handle number 1. Then we implement eventually, actually implement or overwrite handle method. Handle abstract method belongs to event handler interface. That's exactly what happened for all these buttons. Okay, whether we use autonomous inner class or lambda expressions whatsoever, that's exactly what happens. Okay, define a handler class, register object with a source object, then implement over or overwrite the handle methods of event handler interface. Okay, that's exactly what happens. So here, cancel button, we use inner class at the beginning because it's useful for defining handler class. And then here we use autonomous inner class with our class name. It combines definer inner class and creating object of class into one step. So instead of 2 steps, we embed it inside new event handler action events, and we override the handle method. Again, here all these things, lambda expressions, can be used to simplify our coding, even though it's a bit difficult to read at the beginning until you get used with it. So if you move up to JavaFX programming, you don't see much about lambda expression in my coding because it's too simplified, it's difficult to follow at the beginning. So I prefer to use autonomous inner class for my demonstrations. So I recommend you to follow autonomous inner class. Then eventually more people using lambda expressions. So you should be familiar with that too. Seems like that's all. Unless I check a minor mistake here and there. I think that's all for today. Thank you.